Now we're going to go through Sensors Class Chapter 13 book review. Ultrasonic sensors are becoming more and more common. Why are they becoming more and more common? Because they're cheap and they're relatively easy to install, and they are easily integrated with automation systems. And what the heck, I can buy a cheap ultrasonic sensor from Automation Direct nowadays. So they're readily available all over the place. They have a pretty broad range in terms of what they can measure. They can easily give you an analog signal to measure a tank height up to 30 feet high pretty cheaply. And they are excellent even in high pressure environments or explosion proof environments or high heat environments, in many, many different environments. Um, though there are some limitations about extreme high pressure and heat when you have some vapor available. So they are cheap and readily available. And so all those other sensors we're looking at, they're bloody expensive in many cases. So those other sensors, you're talking $500 to $1,000 sensors, whereas a cheap ultrasonic sensor might be 130 bucks or 300 bucks. So they're really getting less and less expensive. As with other sensors, ultrasonic sensors also have point level measurement, kind of similar to the sensors that we saw earlier. They run them in sideways at a high level in the tank. And then when the liquid floats up around the ultrasonic probe, the ultrasonic signal is dampened, and that dampened signal is used in electronics as a trigger to say, yep, I've achieved a high level. More commonly, though, well, there's this tuning sensor as well. We're going to kind of glance through that. Works the same as the other sensor, but you're using two tuning forks, and the one fork transmits to the other until it's surrounded by liquid. Then the vibration frequency changes. We also have pulsed radar, and the more common one of ultrasonic sensor is downward facing ultrasonic sensor here. That's shown on the bottom of page 158. This is the kind that's becoming more and more prevalent. And let me share my screen here with you. And this basically, it's just like an ultrasound would be, instead of bouncing off a baby and giving you lovely baby pictures, I'm sending these sound waves down straight into a tank, and it bounces off the surface of the liquid in the tank and returns back. And that differential in time tells me how far down that level is. So it works great for a whole bunch of liquids, especially flat, calm liquids. Doesn't work so well if it's bubbling and boiling, or if there's a whole lot of vapor, or if there's surface foam or agitation. Those all make any kind of sensor work a little wonky. They usually have a long range, longer than 26 feet here. Sometimes they can have a range of 35 or more feet, depending on the sensor. So these are excellent little sensors out there. And similar to the ultrasonic sensor, we also have radar sensors that use the radar, the radio waves to bounce off even bigger tanks. So you can have extremely large tanks. And you could change the frequency of the radar to bounce off of a variety of different liquids, even if there's some sort of vapor, dust, or bubbles in the way. You can get better performance out of your radar sensor. These tend to be a lot more expensive, though. And then drivers nearby are constantly slowing down. I'm just joking about that, actually. So radar just uses radio beam. Radar works great bouncing against all kinds of materials. We have pulse radar, just like we have pulse radar out on the roads. Finally, on page 161, we get into lasers. They use light radiation to bounce off the surface and back up. So lasers work very similarly. You need a sensor that can sense that light coming back up in the right bandwidth that it was sent back down. Typical bandwidth, the wavelength of the light is 900 nanometers. Once again, you got a problem with dust and vapor because that can stop the laser light. Lasers are also a lot more expensive. So every single one of these sensors, when you buy them, you need to pick the right one for your application.